What's up? What's up? It's the lesson for Tuesday, November 5th, 2024. Sorry I'm getting this lesson out to you guys late, but if you checked modules, you guys saw the assignment. We already keep going. But anyway, let's get this going. Today is election day. We got 7 days left till the end of the trimester. Let's keep it pushing. So today is election day. So I voted yesterday. It was actually pretty cool to actually go down to the place where they actually count the votes. So I actually got to see them in that process. So I was putting my little ballots in there yesterday, so that was on Monday. And then also hey, it should be a crazy one. Hopefully we'll find out by tomorrow. That should be about right. Depends. If it's really close, it'll take longer. If it's not so close, right, then it'll be shorter. So it really just depends. So we'll see who wins tomorrow. And it's not just the president, but there's all these other things that are up. I saw some people were re-electing the treasurers for their county. Some people were about sales taxes and things for the school. And there's all kinds of things who's going to be on the school board. Also, people's sheriff. If you live in the county, a sheriff is really important to you. So all of these different things are going on, and it's important to get out there and vote because it's not just the president. Where I live, hey, we're voting for who's going to be the mayor of the city. That's very important to me because the mayor of the city is making like practical changes, like right on top of things. So you want to definitely get out there and vote because it's more than just the president. There is the president of the United States, but then there's all these other things that you're also voting for. Some of it is judges and different things. So make your voice known. And you know what's crazy is some of you, because I teach 8th graders, so some of y'all who are 14, you turn 14 like September, October in California, you'll probably still be able to register to vote. You might be voting for the next president. Woo! Think about that. Think about that one. That's wild times. Okay. Cool. We wanted to talk about this. This is from the quiz and a couple of things. The reason I pulled up this, and this is some information I pulled from quizzes because I went through and graded everything in quizzes. I haven't quite gotten that into Aries. It's been a slow process. But anyway, long story short, I wanted to go over this one because of the fact that so many people got it wrong, okay? And so let me pause because I think I want to get a pencil up in there. Okay, so let's go ahead and turn on the pen. Okay, so I just want to say, number one, this is how I got these answers. I just said 2 plus 2 is 4. I said 5 plus 5 is 10. And then, hey, 5 plus 5 is 10, plus 2 is 12, plus 2 more is 14. That's how I got these answers. That's all I did. I just added those up. That's how I got all the fake answers. Now, the answer that is correct is 0. Now, how that works out is, hey, this is pushing against and against, right? So then that's going to be 5 minus 5, which is going to be equal to 0, okay? And then this is pulling up, and this is pulling down, which means, again, that is against, which means it's subtraction. So 2 minus 2 is actually 0, and that means the net force is 0. And that's how we got to there. Now, I didn't talk about having 2 sets of forces, but again, if you just followed the same pattern of the things that I told you, that, hey, if the arrows are going in the same direction, right, then it's going to be addition, right, because the forces are combining. But if the arrows are going in opposite directions, and in this case, you would be like, oh, this is down, and then this is up. Again, the arrows are in opposite directions, so they're going against, and you would just do some subtraction. All right, cool. Let's go ahead and move on to the next one. All right, the next one, again, a large portion of students got it wrong. So this is why I'm like, oh, let's go over it. And remember, magnetic force. Does magnetic force have to actually touch the object in order to be able to affect it? No, so it is a force at a distance, okay? So that's what it should have been. This one I actually misspelled. It should have been contact force, but it's contact force, and that is not it. A weak force, that depends on the source, the magnet itself. And then magnetic force typically is not a balanced force. It's going to cause motion, which would be an unbalanced force. So it's going to cause a change in motion. So that's going to be an unbalanced force. All right, let's keep it pushing here. So if a car goes from 70 to 55, that is a change in speed, right? So that's not just speed itself, and that's also not velocity, because velocity is direction, is speed plus direction, right? So both of those things together, okay? So it's like no, okay? So then acceleration is a change in speed up, a change in speed down, or a change, so like a turn, right? A turn, so a change in direction. So acceleration is all three of those. That is what we have here. That is why it's acceleration. Deacceleration is not a thing. I do want to just make sure to say either there is a and when we have acceleration, it's kind of like temperature. Temperature is measuring for heat. Acceleration is just measuring for a change in speed. Either there's a large change in speed or there's a small change in speed, but either way it's going to be acceleration. So that's why increasing, decreasing, or a turn, either one of those, we have acceleration. Okay, so the most students got this question wrong, so I just want to bring clarity to that. So remember, if the speed increases or decreases, or if there's a change in direction, any of those are going to be acceleration. Okay, cool. We are off of the quiz, and I will get those things updated in the next couple of days. My goal is to have all the grades in the book by the time we leave on Friday. That is my goal. So that might take a couple of days to get there. So just be patient with your boy. All right, now let's go ahead and play this video. Please pay attention. The video is rather quick, so let's go ahead and just pay attention. Hopefully you've heard of these variables before. If not, we're going to go over them right now.
In most science experiments, you will have three variables: the independent variable, dependent variable, and control variable.
Hold on. Let's try that again. There was music playing in the background over the video. I was like, nah, it's too much. Let's try that again.
In most science experiments,
Here we
you
go.
will have three variables: the independent variable,
Yep.
dependent variable,
Yes, sir.
and control variable.
Yes, sir.
An independent variable, also called the manipulated variable, has the ability to stand alone. It is the variable you are changing or manipulating. In simple terms, you change the independent variable. You will find it on the x-axis. The dependent variable, also called the responding variable, depends on the independent variable. It is the variable you are measuring. In simple terms, the dependent variable is what you measure. You will find it on the y-axis. Control variables are variables that need to remain constant for accurate results. Let's take a look at a simple example. I would like to know if higher air pressure in my car tires will increase my gas mileage. I will test my car at 20 psi and then at 35 psi and see if the miles per gallon changes. The different air pressure will be the independent variable.
Yeah.
It is what I'm changing. Measuring the miles per gallon is the dependent
The thing I'm
variable.
going to measure.
It's what I'm measuring.
Facts.
And driving the same car each time
Control.
would be one control variable. This will help keep the results constant.
Facts.
So in summary, the independent variable is what is changed.
Yes.
The dependent variable is what you measure.
Yeah.
And control variables are variables that don't change that help keep the results accurate. Remember, kindness multiplies kindness. Thanks for watching.
Yes, sir. I like that dog. I like that dog. Can I pet that dog? All right. Let's keep it pushing, and then we're gonna do some notes right here. I don't know what's going on. I gotta pause. All right, get these notes in your journal. Pause as you see fit. So the independent variable, right, is the manipulated variable. This is the variable that you can change, and this is what is going to be graphed on the x-axis. Again, pause it because I'm gonna do some talking. So I'm about to go full screen. So pause it to get this written in, and then unpause when you're ready. So. All right, boom. So let's talk about this. I got this written up over here. Let me get myself a marker. What am I even saying? I got one right in my pocket. Okay, so right here, hopefully you guys are good with this thing and seeing this. And so we said the x-axis, that's going to be where our independent variable is at. And then the y-axis, that's going to be where our dependent variable is at. So he said the thing that he's going to change, the thing that he's going to manipulate, is what is the tire pressure. So PSI is tire pressure, in case you're like, what is PSI? That's pressure per square inch. Okay, that's all that is. So that is your tire pressure. That's the unit, and that's what they call it, okay? All right, so he said he's going to go 20, and then we have another one at 35. And then what he's going to measure is going to go on the y-axis, which is how many miles per gallon is he going to be able to get. Now, typically let me see if the light will actually make it, that won't make any difference. I don't know if it makes any difference. But typically, okay, what's going to happen is we're going to be in this quadrant here. And the reason that usually in science we're in this quadrant is because that quadrant is the positive quadrant, right? So most of our data in science is positive. It's not always the case, but majority of the data is going to be positive. So what we're going to end up doing, I don't know if that helped out, but so if at 20 psi, let's just say he got 15 miles to the gallon, we would mark that right here, okay? So again, our x coordinate is 20, our y coordinate is 15. Let's just say at 35 psi, he got 20. So then we would make that right here, okay? And that's just like graphing. So if I put the x and the y together, it would be like this. All right, so x is 35, and I'm going to put the unit because that is important. I'm going to put psi, comma, and then 20, and I'm going to put 20 miles per gallon. And that would be the x, y coordinate for that dot right there, right? So hopefully you guys are cool with all of that and say, oh, well, this is my x, right? And this is my y. Boom. And that's why down here on the x-axis and then 20 on the y-axis. Don't worry, we'll talk more about that. I know you're going over the same kind of things like finding the slope, getting the x-y coordinate. I just wanted to say like, yo, it's the same thing in science as it is in math. It's the same math that we're doing. So learn it over there and practice it in math, and then you're also going to be learning it over here, and it'll give you it'll help double down on your understanding. All right, cool. So there is all of that. Now, let's go ahead and move to the next thing, okay? So the dependent variable, again, is the responding variable. It's the variable you measure, and that's graphed on the y-axis, okay? So again, that's going to be graphed on the y-axis. Pause to get these notes in there because there's not much for me to say. I do want to say, usually when I say dependent variable, the thing that I think of or how I try to like phrase it up in my brain, here I'll get my pen on it, is I'm like dependent variable, boom. That's the thing that I'm going to measure. That also is the data. That's the data that's going to come out of the experiment. Again, the data so dependent is the data, the things that I'm going to be writing down, what I am going to measure. That's the most important, and y-axis. The thing I'm going to measure, and it's the y-axis, okay? All right, cool. Let's move to the next one. All right, and the last one is the control variables. These are the things that I'm going to want to keep the same. So what are the things that I'm going to want to keep the same in this case? And he said this. So, and these are the variables that need to remain constant for accurate results. So he was like, oh, drive the same car. I would also add same tires, right? So you want to keep the same tires on the car. Okay, cool. How about this? Same route. You want to drive the same route, right? Or number of miles and the same direction. Because 20 miles uphill is different than 20 miles downhill. So you want to drive the same route and the same amount of miles in a car. One other thing you might want to do is time of day, because time of day is also about temperature as well. So the temperature may change how gas consumption works. So you want to drive the same car, same tire, same route, same time of day, same amount of miles. So all of those things would be what we would call control variables, and those things you want to keep all the same so that you know that that thing that you changed, which was the tire pressure, is the thing that is causing the change in the gas consumption or the miles per gallon that you're getting in the car. Okay? All right, cool. Now, next to, I want to say this. I want to put this out there. Do I have my, oh, it's right here. Bam. So all you have to do is next to independent variable, put a big if, and next to dependent variable, put a big then. You do not have to write all of this. Just again, next to your independent variable, put a big if, and then next to your dependent variable, put a big then. Okay, and then we're gonna do some yapping right here. So, and this is because there's this word called hypothesis. So hopefully you've heard of this word before. I do not want to write in that color. Like, give me that blue. So if I put 35 psi in my tires, right? And this is how it works. So that is the independent variable, okay? So the 35 psi, that is my independent variable. Then, right? Then I will what? Then I will get and this is where you've got it. This is the part of the hypothesis where you're kind of making an educated guess. I will get I'm going to go with higher. what was that last thing? Oh, miles per gallon. I will get a higher miles per gallon. Does that make sense? And that's how a hypothesis works with the independent dependent variable. Again, the independent variable is up here, 35, and then getting a higher miles per gallon. That's the thing I'm going to measure. That's going to be the data that I'm getting out of there. Okay, cool. So that's how it actually would work in practical sense. Now we're going to go ahead. We've already got all of these notes, so we should be good. We're going to skip ahead of this one, and then we're going to go to this assignment. So go ahead and go to your modules and pull up this assignment that says independent, dependent, and control variables practice. So I'm going to go ahead and go over here. I'm going to go there, go to my courses. I'm going to go to period number 2. I did want to show you guys this because it seems like some people don't know, but on your first page, if you scroll down, coming up assignments, a lot of times the assignments will be right there. Okay. And then, but I don't think it's going to be in the upcoming because it is due today. So it's due today on the 6th. And I think if you're watching this video, then you'll see it's due today on the 6th. So right here, and I actually got to make a change because I put that it was due November 5th. That's my bad. So I'm going to go ahead and reassign it and make it on the 6th. Boom. Bam. Done. So now it's due on the 6th. Okay, so just pull up this assignment. As you can see, a couple people have already submitted it. You're just going to click here. And then file, make yourself a copy there. So file, make yourself a copy. Blot out. And then I'm going to go ahead and put my name on it. I'm going to put Mr. Farr. Right? Cool. And then I'm going to go ahead and put it inside of my science folder. So I want to do that. Science folder, select. Now we're done. Make a copy. Cool. So I'm going to walk through the first one with you guys, and then you guys can start on this assignment. Okay. So very first thing, it says read the information about each experiment and record the independent. That's the IV, which is down there. Dependent, which is the DV, which is down there as well, and the control variables, which again is right here, the CV, and make sure to list as many control variables as possible. I'm going to make this a little bit bigger, be easier to see on your guys' screen. Okay, so the very first example is, will an egg float higher in water with more salt? Now, the thing that we can control, right, the thing that we're going to be, not control, the thing that we can change or manipulate, I got to be precise with my words, that we can change or manipulate in the experiment is the amount of salt in the water. So that's the very first thing. So that would be our independent variable. We could have all the way from no salt to a lot of salt, right? So that is the thing that we are going to change or manipulate. Now, dependent variable, that thing, right? And if we scroll up, I actually have the definition right. That's the responding variable, the variable that you're going to measure, right? So with that being said, what's the thing we're going to measure? And usually as soon as you look at the question, it usually will tell you. So will an egg float higher in water? So, how high the egg floats. That would be the dependent variable. That's the thing we're going to measure. Now the control variable, the thing that we are going to control, we would say like this, amount of water. How about water source? So like where we're going to get the water from, right? How about container? Like whatever we're going to put the water in. Okay, that's cool. Now let's talk about the egg. So we're going to keep type of egg, or why don't we say source of egg, right? Source or type of egg, we're going to keep that exactly the same because you don't want to use like an ostrich egg and then a chicken egg, right? You also don't want to use eggs from the store and then mix those in with eggs from chickens because I know some of y'all raise chickens. So that's a whole nother thing. So type of egg, right? And then some people were like, if we use boiled eggs or if we use non-cooked eggs, we should use all the same type. That's true because that changes things, okay? Then for also more control variables for the salt, type of salt, right? Type of salt. So we should use the same type of salt because most of you guys have a whole bunch of different types of salts in your at your house. Some people have garlic salt, Epsom salt. Some people have rock salt, table salt, sea salt, right? So there's all kinds of different salts. So whatever salt you're going to use the same type of salt. And then some people also said temperature of water. So that also should remain the same. So as you can see, there are many control variables. And the more complex the experiment is going to be, then the more control variables you are going to need. So let's just go down and let's do the second one as well, and then we're going to end this video. There are 10 of them, so you need to do the rest of them on your own, but let's just do one more. So Ivan and Braxton want to know if stretching the rubber band at different lengths affects how far the rubber band will fly. What is the thing we're going to measure? Hopefully you said, how far will the rubber band fly? And that gives you automatic dependent variable. So if you figure out what the question is they're trying to figure out, that is the thing we're going to measure. That is the dependent variable. How far the rubber band will fly. Automatic. So what is the thing that we can change or manipulate in the experiment? The thing that we're going to change or manipulate is how far the rubber band is stretched, right? So how far the rubber band is stretched. Okay, cool. Now we're already down to control variables. We would say rubber band type, right? So whatever rubber band type we use, we got to use the same type on it. Rubber band type, right? We would say also a place's location, because yesterday it was quite windy outside. So if we did it outside with the wind, that might change our results. So location, and I said preferably let's do it inside. That's another thing that probably would cut down on that, right? So, and then we could control the temperature. We could probably control the wind if we do these things inside, okay? So rubber band type, location, and then since this is a very simple experiment, we could say unit of measurement, right? So that also would be a thing, like how we're going to measure. They said they're going to measure in centimeters, so we want to make sure that that's how we're measuring. Also, one other thing to consider is measuring on first hit, or first, I would say let's go with first collision with the ground. And someone, because it could be, because some people want to be like, is it when the rubber band first hits the ground, or is it where the rubber band ends up, right? Like at the very end of it when it stops its motion. So we're like measuring on the first collision with the ground. So where it first hits the ground, that's what they're gonna measure. So again, the simple, and then one last one that someone brought up, and I thought this one was a really good one, is use a new rubber band, right, for each stretch length. And why would you do that? Because as you keep stretching a rubber band, it's losing some of its elasticity. So the amount of potential energy or kinetic energy you can get out of that thing is changing every time you're stretching it. So that also would be something you would want to take into consideration as well. So as you can see, those are also some of the control variables. Now I'm just going to scroll down. There are an additional 8 more that you need to actually do. So make sure that you guys get all of those in there and going. And this assignment is due on the 6th. All right, y'all. Peace.